Hello, everybody. Hope you had a great lunch. Really appreciate you attending the session today. My name's Tod Golding, and I'm a partner solutions architect, and I focus on the SaaS specialty. And as part of being focused on SaaS, I spend a ton of my time working with customers who either are migrating solutions to a SaaS delivery model or going greenfield delivery on a solution. And generally, I'm helping them with SaaS best practices, design, and architectural principles. And as part of that discussion, we typically start that discussion on the left-hand side of this diagram, right? A lot of the initial work we do is all about building this foundation of multi-tenant concepts, right? So it's identity and billing, and we have to figure out how to do data partitioning. And there's all these sort of foundational building blocks that are core to building a really good SaaS solution. And you rightfully spend a ton of your energy on these problems. But the truth is, if you're going to spend all this energy of adopting a SaaS delivery model and you're going to get all invested in all the goodness of a multi-tenant environment, there's also a whole nother realm of opportunities to think about what can I do with my environment? What are the architectural things I can do to actually optimize and bring new efficiencies and bring new possibilities to my environment once I have all the levers and the knobs that are part of being multi-tenant. And so today for our discussion, it's more about that realm of the problem, right? I've got my environment built. I have these really good multi-tenant constructs. I've got AWS constructs at my disposal. What can I do to help the business either control costs better or bring a better experience to my customers and so on? And that's the focus of the discussion today. Now, the architect in me says, well, if you're going to have a discussion about optimization patterns, and the guy who likes his Gang of Four book says that you ought to have some taxonomy for talking about what those are, some classification of the optimization bits. And for me, at least right now, these are the buckets that I sort of think optimization naturally fall into. I think this is definitely an evolving space, and I bet if I talk to several of you, I'd find out you have all new ideas and categories of optimization. But for now, these are the buckets that I see as I work with customers. And so we have tenant experience optimization. To me, this is where we say, are there opportunities in our SaaS solution to look at the trends and the usage patterns and the workflows in our applications and deliver very focused optimizations to those tenants so that those tenants can get an improved experience. And I have to be a little vague about that because that experience could vary from domain to domain, right? It could be a really snappy web UI, but it could also be something that's a better streaming media solution or a big data solution or something in IoT. The main point here is that there's some opportunity for the end user to get an improved experience. Usually comes in the way of throughput. Data partitioning is the other area you want to look at. And when I talk about partitioning, I'm specifically talking about how can we look at the ways that we actually represent our data in a SaaS solution and optimize the actual I/O of that data, right? How do we acquire data more efficiently in a multi-tenant model, and how do we push data in a model where we're getting the most bang for our buck? And what are some of the ways that might be leveraging different AWS storage technologies, or what are the ways that I just think about how I fundamentally partition the data itself to maximize the throughput while sort of minimizing costs for the business. The third category, admittedly, is a category that's a little still fuzzy for me around the edges. But I have this belief that through policies and through configuration and sort of acknowledging that all tenants aren't created equal and that we stratify tenants intentionally in the world of SaaS, that I can introduce policies and say, I have different flows through my system based on the policies that are attached to you as a tenant. And I can actually give different experiences to you that are optimized around the kind of tenant you are, right? If you're a gold tenant and you're paying $49.95 a month, I might give you a different experience through policies than I might give to the bronze customer who's paying 20 grand a month, right? And so can I use policies to both optimize and sort of stratify my population of tenants? And then the last one, no discussion of optimization would be complete without bringing up just load and cost, right? Optimization. That's everybody's sort of goal in any architecture, but in a multi-tenant world, we'll look at this and we'll see that there are very specific things, very specific trends in the way that workflow happens inside of load happens inside a multi-tenant environment, and different mechanisms we have sort of for matching tenant load with actual infrastructure load, right? So that can we get those two to line up as best we can. And then along the side here, I just wanted to convey that sort of spanning all of this are metrics and profiling, right? Almost every flavor of optimization we're going to talk about here relies on a really good foundation of metrics and knowledge that can drive how and where you decide to apply optimization in your environment. And to me, the truth is, most of the categories that I've come up here, most of the opportunities I've seen, were mostly derived from the idea that somebody saw some pattern in their metrics and said, my tenants generally behave these ways, and based on the knowledge I have about their behavior, I have the opportunity to introduce new kinds of optimizations that might help my specific domain. So let's start with this notion of tenant experience optimization. And for me, I've really enjoyed this dimension of SaaS for me, which is the reality and the curse, maybe, that the population of tenants I have running in my system, what they're doing and how much load they're putting on my environment and what their current activity is a continually moving target. And what I find is the profile of the tenants and what they're doing in real time represents an opportunity for me to bring optimization to them, all right, in a very selective way. So if you look at this graph I have here, if I, at a moment in time, if this were a snapshot of my current system, I could say I have some classification of tenants who are currently idle. And idle doesn't mean they're truly using the system, not using the system, but they're using it. If they are using it, they're using it in a very minimal way. They're imposing almost no load on the system, and whatever that load is, it's negligible. And then I have some other group of tenants that I call active tenants. They're using the system, they're pushing buttons and levers, they're creating some load for me, but they're not really doing anything that's pushing the scale of my environment in any significant way. They're not really pushing any boundaries that are really making my environment respond in any significant way. And then somewhere within that subset is this group of tenants that I call the busy tenants, right? And these are the tenants who are truly actively using my system, and they're pushing the boundaries of the system, they're forcing scaling events, they're imposing heavy load on the environment. And when I looked at this data and I looked at the behaviors of my tenants like in this state, I realized that when I go to apply an experience optimization here, when I try to provide my tenants a better experience, I don't really have to have a solution that spans all the tenants in my environment. If I can somehow just target the busy tenants and bring better performance to those tenants in real time, I can do really creative things in terms of optimizing their experience without having to go back to the business and say, we're going to have to build out and invest in this big new infrastructural footprint, and there's all this big cost. Instead, I can do these very incremental, small things that still have tons of value, which to me is right in the spirit of SaaS, right? Which is, I've got all these people poured into this multi-tenant setting. I now have dynamics around how they're consuming bits, and I can target them with performance in real time. But as part of doing that, I have to acknowledge that the profile is continually changing. So when I look at this model, if I look at it in another hour, I might find that the busy tenants have moved now, and that the busy tenants is an entirely different population. And if I look in another 20 minutes, it might be a different population of tenants. So whatever my strategy is, it can't just be as static as I figured out who they are, I'll bring some static sort of solution to that set of tenants and I'm done. I've got to have a dynamic model that is real-time bringing the resources and accommodating the fact that it's a moving target. Now, what's an example of this, right? Is there an example where I've applied this strategy? And I worked on an e-commerce solution, a SaaS e-commerce solution, that I think is a good example of this in action, which is in this SaaS e-commerce solution, I had these merchants. These merchants are traditional e-commerce kind of vendors, and they have product catalog, and they're selling products. And in their underlying architecture, we had an RDS cluster, essentially, that held our catalog data. And in looking at the analytics and the behavior of our tenants, we said, we noticed that tenants who had a better experience with the catalog, who had a more snappy experience with the catalog, that those tenants tended to convert to buyers more successfully. And so we said, gosh, if we could just cache their catalog, that would be an awesome way to give them better performance. That would return more value to the bottom line of the business. But we scratched our head and said, well, we can't cache everybody's catalog because now we're going to have to build out this huge cache cluster, and then the economics of that are not going to make a lot of sense for the business. Well, you can imagine this is sort of a perfect fit for the example I talked about, right? So if we look at a workflow in here and I have this cache in place, and I have tenant 2 as one of my tenants, and that tenant says, hey, I would like some catalog data. When that tenant hits my data access layer, that data access layer is going to go ask, hey, is this tenant's catalog actually cached? And it's going to look at this table I'm maintaining of which tenants are currently in the cache and which aren't. Traditional model for dictionary or hash or whatever you want to look these up. It says, no, it's not in here. Okay, then I'll go over to the RDS cluster, I'll go to the read replica, I'll pull the catalog out of the read replica, I'll return it to the tenant. Now, after I return it to the tenant, though, I'm going to go over to this sort of black box I have here on the screen just called the cache manager. And we'll dig into what that cache manager is doing more in a few minutes. But I'm going to tell that cache manager, hey, tenant 2 just asked for catalog data. Can you decide whether it should be in the cache or not on an ongoing basis? The cache manager looks at it. The cache manager asks some question to say, is this a busy tenant? Has this tenant been classified as busy or not? They say, yeah, it's a busy tenant. Okay, well then I'll push this tenant's catalog into the cache, and then the cache manager will update the cache status table, and now a subsequent request for a catalog from tenant 2 will immediately be processed from the cache, and that busy tenant now will be getting a much better experience in their catalog. And so in this scenario, I've very much levered this model that I've talked about, right? Identified the busy tenant and brought a good tenant experience to that tenant without incurring a huge sort of incremental increase in the infrastructure footprint of my application. Now, the key point I want you to take away is this is one sample of this. The bigger takeaway of this is if I know who these busy tenants are, there may be any number of opportunities to apply an optimization like this. This is just one sample of how you might attack it. The key point is to gravitate to that data and that classification and then figure out what to do with it. Now, the question I often get then is, okay, that's cool, you got the busy tenants, but how do I identify a busy tenant? Like, what would the approach be to do that? And the truth is that each domain and its classification of a busy tenant might be different, right? Some people would say, well, a really chatty set of services going on behalf of that tenant and a lot of interactions with that tenant might be it. Well, no, that might not be it, because it might turn out that some of the operations tenants are doing are actually imposing more load. They're less chatty, but the calls they're making are pushing CPU or memory in some way. So for me, on a domain-by-domain basis, this is often a very long discussion of what would the metrics be in your environment that would say this is a busy tenant, right? And you have to sit down and decide how to instrument those bits into your services. So you can't just look at the logs and CloudWatch and all the other metrics that you'd normally have. You're likely going to have to introduce and invent some metrics of your own and make those the metrics that you're publishing from the services of your application. Now, the good news is if we come up with a good way to publish those metrics, we have really good tooling and technologies on the other side of that to aggregate those metrics and ask good questions of them. So in this case, I've shown Elasticsearch here. I'm running a little cluster down at the bottom. I'm publishing events from my services. Those services, and then that data is being aggregated in this Elasticsearch cluster, and then now I introduce a tenant analytics service here, right? And this whole service's job is to say, let me expose a REST API that lets me ask hard questions of that data, of which one of the questions it answers is this tenant a busy tenant? And the whole point here of separating tenant analytics service from the tenant cache manager is because I see tenant cache manager as one of the clients of that tenant analytics service, I can see a realm of other possibilities here around that tenant analytics service that would be answering more interesting questions about the profile of my tenant. So for me, if I can isolate that and make that a standalone concept, then as I look for more additional opportunities for optimization, that service can provide a natural abstracted away view of answering and tuning and arriving at good tenant analytics. Now, the other question related to this one, and I think even though this is based on a single scenario, the pattern of this will come up no matter which sort of optimization strategy you take. But here you'll say, well, I use this cache. The next not logical question is, how big should that cache be? Like, not every tenant can go in the cache. That wouldn't be practical because we said we wanted to narrow the overall size of the cache. But if you look at the blue line on my graph here, which is a graph of the number of busy tenants I'm detecting, you can see that there are times when the number of busy tenants spikes and I get this sort of erratic behavior. And so do I say as that spikes that I should over-provision the cache and create a much bigger cache to create however many busy tenants there are? Well, that doesn't seem like a very practical solution either. And so the answer usually is here that you will find some equilibrium here, some point at which the cache is big enough that it's accommodating an appropriate number of tenants to yield the value you want, but not oversized in a way that it's eating up too much cost. Now, within the sizing of this cache, you'll often say, well, wait a minute, I still have certain tenants that I wish would get rated higher than others. So if 20 tenants are considered busy right now, but there are 5 tenants in there that are my 5 tenants that are the sort of bread and butter of my business, how can I weight those tenants? How can I give them a higher rating so that I'm sure they always get preferential treatment? And this is where you'll see in the top tenant cache here, I've added a weight column, right? And I've really added this really as a way of saying you can introduce your own data and your own mechanisms and metrics in here that can further influence the sizing of this cache to say who really gets to be at the top, who doesn't, and it can be a super effective strategy for this. What I've seen in the contrary to this is that I've seen people say, well, we have these 5 tenants that are close to our business. We won't do this with a dynamic mechanism. We'll set these 5 tenants to always get the cache. And then what happens is there are times when those 5 tenants aren't the 5 busy tenants. So why not give those resources to the 5 that actually are right now, even if they're small and they're running in a smaller tier? If they're the 5 top tenants and their weighting system hasn't pushed anybody else to the top of the line, why not give it to them? I'd much rather have that be happening dynamically and returning that value to whoever's currently pushing my system. So what are the takeaways here? For me, this tenant flavor of optimization is all of me about making the right kind of tenant successful. And you should be, as part of looking at your SaaS solution, looking at what are the patterns and the profiles of usages and tenants. And you should be pushing hard for metrics around all of that to say, how can I figure out which tenants are relevant and how are they using my system and how can I classify their usage, right? I mean, I worked on that tenant e-commerce system, and we found out after just poking a little bit at the analytics that 90% of our tenants sold like 80% of the volume of sales on it, and the other 10% were selling almost nothing. And that changed the way we shaped our architecture. But I couldn't know that without pushing hard for the metrics to find that out. And so the metrics inform the optimization. Whatever you do with optimization here, whatever sort of analytics you introduce here, please make it a real-time notion, right? Because you acknowledge the fact that whatever's going on in a multi-tenant environment, it's changing moment to moment. The other part of this is these optimizations are awesome, and we're, as architects and technologists, it's very fun to play with and bring all these cool tools and services to bear to solve these optimization problems. But what I also find is sometimes people will introduce these very complex solutions to get optimizations, and then the optimizations themselves become a part of the fragility of the system, and they have a big DevOps footprint, and they're complex to maintain, and they're complex to manage, and suddenly the thing you introduced ends up becoming a burden to the overall solution. So limit its footprint and limit its complexity. The other bit of this is no matter how you go after these analytics, I guarantee you when you first start, whatever you thought were the right analytics or whatever the right metrics you thought were to classify the tenants were, you're almost invariably going to be wrong. So for me, build the algorithm, capture the metrics, look at the metrics, and then question whether or not you're really looking at the right metrics. And then if you've done this algorithmically, you can refine the metrics and the approach over time. And then the last bit here, To me, these metrics, they're great for optimizing your environment and optimizing tenant experience, but they're also great visibility for the operational side of the house, right? The operational side of the house often has interest in who's the busy tenants and what's the profile of tenants and what are the metrics about how they're currently using the system. So don't see optimization as the only consumer of this data. The next area we're going to look at is data partitioning. And specifically, like I said, we're going to look at, okay, with AWS services and different storage services, and generally how I/O of storage in a partition environment, how can we optimize in here? How can we return the best result? And this starts with, and I've talked about this in my other session earlier today, this all starts with understanding the profile of your tenants and acknowledging that your tenants have different size of data, right? That tenants aren't somehow all equal and they all have the same footprint and they all land in your database the same way. You will have tenants that are huge and you'll have tons of tenants that are tiny, and because of their distribution is uneven, the uneven of that distribution has a way of imposing extra cost and undermining the performance of your storage. And so we have to find a strategy and an optimization strategy that acknowledges this distribution challenge. The other reality is we have to face is that even within a tenant, that distribution may not be the same across tables. So here I've got two tables, an account table and an activity table. And you'll see that tenant 2 in this model has a very is very busy in the account table. But then when I look at the activity table, tenant 2 has almost no impact on that table. But instead, tenant 4 and tenant 6 are consuming most of the space there, right? So I don't just need a strategy that is a global tenant-wide strategy. Within a tenant, I need a strategy that says table to table, how can I deal with these anomalies in the data? Now, there are also different ways that these sizes of these variations in size can undermine performance of your system. If we're using one of the storage technologies that relies on an instance, right? If I'm using RDS or something and I've picked a certain size instance and that instance is managing and storing my data, what I'm going to find is that if I'm sharding these tenants in a multi-tenant environment and too many of the large tenants end up associated with a given instance, then I'm actually going to impose load disproportionately on that instance. So CPU, memory, I/O of that instance itself could become a bottleneck for me, and that I might have to now go change the size of that instance because I didn't distribute those tenants appropriately across the instances. So we can get this sort of compute bottleneck, but we can also get a key bottleneck, right? I talked about this in my other session here, which is that if we looked at this DynamoDB table and we said, what's the distribution of a tenant's data across the key, and tenant 1 is this extremely large tenant, you're going to see that tenant 1 is consuming like almost all of the key space here, and tenant 2 is barely consuming it, and yet tenant 2's performance is going to be undermined by tenant 1's data distribution. And so then what do we do in these situations? We'll throw IOPS at this, we'll throw resources at these problems, because that's all we're left with, right? If you don't resolve this from the beginning, then you're left with data that's unevenly distributed, and you're like, well, I can either reshard it and migrate it and take a different approach to the data distribution, or throw more resources at it, which throws more cost at it. So the common approach to solving this is sharding the shards, right? So typically we would just say, hey, if I'm indexing data here, that I would just say throw the tenant ID in as the key, that is the partition key, and that's adequate. Well, now we're saying that doesn't work because of the data distribution. So instead we have to say each tenant goes through some level of indirection, and then that tenant is associated with one or more shards, and those shards will be the keys of our solution. And now we can control their distribution because we can control how many shards are associated with a tenant. So in this simple example here, I have 2 tenants. I have some black boxes that are the shard analytics that are saying, analyzing and looking at the activity of a given tenant and saying, what should the distribution of data be for one of these tenants? And in this case, it says, hey, tenant 1 is a much more busy tenant, and so we've added 3 shards for this tenant over time. And you can imagine in real time that as we're assessing the data, I might even add a 4th and a 5th shard for tenant 1, whereas tenant 2 is a moderately sized tenant. They're not consuming a lot of data, and they might end up with 2 and only have 2 for their entire lifespan. Now, DynamoDB, if we were to look at this playing out in DynamoDB, you'd see this indirection here. So we have a table here with a tenant ID in it. It has the customer table referenced here, and then I have some sharding data about that tenant, right? How many shards do they have, what the sizes of the shards are, whatever data I need about the shards. Specifically, I have the shard IDs here. And then you see the shard IDs are what actually land in the partition key. So now whenever I need to access this data, yes, I'm going to have to go through the tenant lookup table and then resolve the tenant lookup table for one of those, for that tenant to which actual shard IDs I'm going to be interacting with in the DynamoDB table. And you can imagine that the sharding scheme for each table and the sharding data for each table for that tenant could be different. Now, if I do this for RDS, it's more about potentially looking about how I'm distributing across instances here, right? So now the tenants have shards, and those shards reference instances, and I can, if I wanted to do this across tables in RDS, I could do that as well, but I still, again, have to introduce something that's a shard of shards in front of all this so that I'm not just putting tenants in any instance and not acknowledging the anomalies in their data distribution. But this gets me around the compute bottlenecks that I talked about earlier. So just like with the tenant experience optimization pattern we talked about, this solution has the same kind of a problem attached to it, right? The same theme attached to it, which is, what are the analytics that should drive my shard optimization? How should I decide what criteria determines somebody gets a new shard, or that a shard's getting full, or that somehow the data is getting distributed unevenly in my environment? And what you tend to find here is that you have to look in your domain. Imagine a big data domain is certainly going to be scaled differently, and the shard analytics are going to look different than somebody who's storing data in S3 or in DynamoDB. And so there are certainly simple answers here. You could be assessing the size of the shards and just continually evaluating that, and then looking back to the tenants and adjusting their sharding scheme. Some people will do round robin. Well, they'll just say, I'm just going to be sure I'm round robin, and I'll rely on the round robin algorithm to be sure that I'm distributing across the shards, although I don't think that accounts for size very actively. Some people will use windows of time. Well, they'll say, I'll open this shard for a window of time, I'll let data go in there, and I know that if I shut the window after 2 days and open a new shard, or 30 days, or whatever's reasonable, and start a new shard, that I'll make sure I never get a hotkey problem there. There is no sort of fixed, de facto sort of approach to this, as much as you sort of have to find the model that works for you. For me, though, the real key point here is at least if you put the shard of shards mechanism in place and you don't have really great analytics, you've at least put yourself in a position to say, in time, I could put better analytics in there. I've even seen people manually just watching the analytics and alerting and alarming whether they're getting sort of a hotkey situation and going in and manually adjusting the sharding of their tenants. I don't prefer that model, but at least that's better than just filling it up and then throwing resources at the problem. So takeaways from this model. Hopefully it's clear that the distribution of data being uneven, it can undermine our I/O experience, right? It's often too late in the process before people realize that I really have an I/O problem with my storage and my multi-tenant solution, and by then my data is all filled up, and now I'm stuck in some migration scenario to try to resolve that. And please acknowledge that the unevenness of that data is going to potentially undermine the cost of your system. So this isn't just about whether it's a good architectural solution or not a good architectural solution. This has a real impact on cost. And it's typically a growing impact on cost. The other bit here is each storage service within AWS's stack, right? How you would solve this for Dynamo versus how you solve it for RDS, how you solve it for Redshift. Each one of them has to have its own unique approach to how you think about doing shard of shards here. But generally, the challenge of this topic for me is always that This strategy really comes down to your domains. When I dig in with teams and I work with teams and we talk about their specifics and their environments, we can typically come up with a good metric for how to manage your sharding, but I can't give you sort of a blanket statement for how to address it. The next area we want to look at is the one that I said is a little bit squishy for me, right, which is this notion of tenant policies. And I would hope that in general in a SaaS system that you've already just introduced some centralized notion of tenant policies. As a general rule, we tend to have configurations of tenants, and we tend to want to have, and we have policies associated with tenants, even if we're not thinking about optimization. And what I like to see is that those policies are represented in data and they're acquired through some centralized service. And if we put all those policies in a common place, we sort of give ourselves a natural opportunity to then also use that same mechanism to introduce optimizations. And in this case, I've shown here is if I can put something in the tenant level and introduce an optimization in data, that optimization might be applied at any number of layers in my architecture. It might be at the actual API entry point, could be within the actual services, might be somewhere down in some data access layer. By having this centrally accessible policy, I get the opportunity to introduce these policies at any one of those layers. Now, the simplest example of applying these policies isn't really about an optimization. It's really just about the typical sort of tiering model that you would apply in a SaaS solution, for any SaaS solution, right? We have gold, platinum, bronze, whatever the tiering structure we have in our environment. And we typically have metrics and data associated with that. Number of users, some cap on the amount of data you can have. There's something associated with each plan. And the policy becomes a very natural place to enforce that, right? So as I try to access data here, you can see that I could pull in these policies, and I could then say, hey, the gold maps to a certain storage limit, and I could use that to raise an alert or alarm back to the user or some administrator to say, hey, you're reaching your cap, or you've got an SLA you're violating, or we're not meeting up to that SLA. It just becomes a great centralized mechanism for enforcing those boundaries. Where it gets more interesting, though, is when you think about using this same mechanism to do workflow-based optimization. So imagine tenant 1 on the left is my gold, and tenant 2 on the right is my bronze. So tenant 1 is paying $49.95 a month, or they're in some free tier. And tenant 2 is one of my premium tenants. They're platinum, and they're paying a premium for their environment. And these two tenants both have three workflows that they're exercising, shown in this green box. In this e-commerce solution, they're going to say, go get me the orders I placed on your store yesterday. And their expectation when I ask to get the orders from yesterday are typically that I want that to be a pretty snappy response. Lots of people are going to be asking that question, and the turnaround, the latency of that ought to be really fast. Scenario 2, get them from the last 30 days. Well, that should be moderately fast, but I could understand if there's a little bit of a delay there. And then if you say get every order I ever created in time, the turnaround on that could be slow. So if I have 3 different workflows with 3 very different expectations of the user, even though this is one operation, get me orders, those 3 different workflows could be optimized differently. And I could use tenant policies as a way of driving that optimization. So on the left-hand side, what you've seen is I've said, you know what, for these 3 workflows, I actually feel like I could offer 3 different data experiences, 3 different storage experiences, leveraging the AWS stack of storage services here, and acknowledge that DynamoDB, while it could really be the great solution for all of this, might have a higher cost footprint than S3, and use that stratification to take the user down different paths depending on which of these workflows they're exercising. So on the left, in scenario 1, I ask for the orders from my orders from yesterday. I'm going to go to DynamoDB. It's all turned up. It's optimized. It's costing me a little more money, but I'm giving a great response for that workflow. Scenario 2, I'm going to use RDS. I'm going to have the orders from the last 30 days in RDS. I'll tune it down a little. I'll expect a little more latency there. And for scenario 3, I'm going to hit S3. I'm going to have archived all your orders into S3. The turnaround will be slower, but I will be paying less in a long-term basis for all those archived orders. So here I've created alignment between a workflow, a specific workflow here, and a tenant and a tenant's policy and the tier that they belong in, and leveraged the strengths of the AWS services and the cost profile of the services to return value back to the business. Now in tenant 2 scenario, because we said they're a premium tenant, tenant 2 is going to get the first 2 workflows always processed by DynamoDB. The third scenario for all orders, they're all going to come from RDS, and there's no S3 in the equation. Because that tenant's paying a premium, we want to return the absolute best result we can. Now, when I drew this scenario up, I don't know how practical it is, right? There's some trade-offs here. Did I introduce too much complexity by introducing all these different storage schemes? What does it mean to migrate from being one type of tenant to the next? And is the overhead of managing this environment too high? And this, I don't want to contradict the idea that we don't want the complexity to be too high. But I think the fundamental point here is still valid, which is if you look at the workflows of your application and you look at them more granularly, you're going to find that there are opportunities to match the expectations of those workflows with different experiences across your tenants. And the key here is giving this value back to the tenant, to the business of saying, hey, we've given you a new way to stratify the tenant experience and a new way to sell it, and that you can say these kind of tenants can now justify why their tier costs more than another tier. That's something the business is typically very interested in. So key takeaways here, well, hopefully, I think I've just emphasized the first point, so we'll move past that one. But in general, even if you don't buy all the sort of optimization here or it doesn't fit for your environment, I would at least like to see you centralizing your policy management and centralizing the management of your tiers. And then understand that the context of any one request could change how you decide to process that request, right? Hopefully here you saw in the orders that the context of each one of those and the expectations of the users changed my expectation of how I was going to process it. And then really look at the distribution of AWS services, especially say you're using a microservice-based model and microservices are processing these moving parts of these different workflows. You could imagine that some workflows could be represented by some microservice with the optimal sort of AWS storage model for that service and an entirely different storage model for some other workflow with some other microservice. And so using the diversity of the AWS services here lets me sort of align my tenants with a cost profile and align me with the AWS service in an optimal way. The last bit here is load optimization, and to me this is one of the most interesting parts of SaaS for me, which is, at least for me in single tenant environments, when I went and looked at the dashboard and the console and the user experience, I could clearly get a view of what day-to-day sort of activity looked like, right? When I look in the console and the dashboard, there weren't, from day to day, from hour to hour, the workloads weren't changing drastically, right? But when I dropped into the dashboard of my multi-tenant environments and I looked at tenant consumption, literally, there was no way for me to predict or understand how or when tenants might spike and when they wouldn't and what I should do to do that. And that complicated my whole sort of cost and load optimization story, because in load and cost optimization, I want to take tenant activity and tenant consumption, and I want to match the graph of infrastructure consumption as closely to that as I can. But not all the mechanisms we use here and the traditional ways that we decompose our applications allow us to get that kind of alignment. And we don't really end up with a really good sense even of what the cost per tenant in our environment is, or really good ideas about how we can tweak and tune our policies to achieve this alignment between these two graphs. Now, an example of this in action is dynamic DynamoDB, right? Dynamic DynamoDB is an open source tool, and it lets me adjust IOPS. And I only include it here because it's a really good example of the goal I'm trying to get to, which is, hey, my blue line shows me consumption, my red line shows me the adjustment of IOPS around that consumption. And the goal here is, yeah, they're not side by side right next to each other, but in general, in real time, keyword, real time, the IOPS here are being adjusted to match the actual activity of the tenants in my system. And to me, that translates directly back to value back to the business and cost savings back to the business. Where it gets more interesting is when we look at how we decompose our system into services, though. Right? When we decompose our system into services, what's the right granularity, especially in a SaaS environment? It's a question I get all the time, like, how big should my services be? And for me, that question is complicated in a multi-tenant environment. In a single-tenant environment, I have this cart service, and within it, I have this notion of checkout and taxation and shipping. And in that single-tenant environment, if you told me, what are the scaling policies for this particular service, I could probably come up with a set of scaling policies that probably worked here, because I have a good sense of, even though there's 3 concepts sort of aggregated into one there, I could probably predict how they need to scale, do okay. But in a multi-tenant world, what I find is, in one moment, checkout might be being used heavily out of the cart service, and in the next minute, shipping is suddenly the thing that's overloaded. So what should my policies be for how and when that thing scales? Well, it depends. It's changing minute by minute, or at least hour by hour. And so even though this is a general principle as part of sort of microservice-based design, this is especially important in a multi-tenant world where we have to say, I have to think about how to decompose my system into small enough services that I can tune the dials and the knobs of consumption here to align the graphs the way I want them to. And if the services are too big and I'm not able to get the graph where I want, I have to find new ways to break the problem apart. Because if I break it apart the right way, I probably got a decent chance, at least from a compute perspective, of getting the consumption and the infrastructure graphs lined up. Now, one of the best examples of this in action to me is the serverless SaaS model. So in a serverless SaaS environment, where I've really looked at Lambda and I've decomposed my system into a series of functions and so on, I have a much better opportunity to deal with this consumption problem, right? So if you look on the left-hand side, you'll see I have a traditional order service. And in that order service, I have create and update and delete and the normal things that I have here, right? But how do I know if delete is this really expensive operation, but it's rarely called, and create's being called all the time, how do I set that order service up to scale? What policy is the right policy for it? On the right-hand side, when you look at that same scenario and that same service broken out into functions, I have a very different set of opportunities here, right? Because now I just say, what are the functions that my tenants need to run? Whatever they are, here they are, and each of them are going to scale independently, and I don't have to write the policies around how they scale. So now, if tomorrow 10 new tenants show up and they onboard into my system, and they're really hammering the delete or the find or some function that didn't used to be running a lot, fine, Lambda will run more of that service. The better side of that is if there's flows through here and paths through here that tenants are rarely running, those functions are just never going to run, and I'm not going to pay for an ounce of consumption for them. That's very different than the service on the left running in either a container or running on an EC2 instance, because no matter what, even if my scale comes all the way down, there's going to be some capacity, some compute that's actually running that I'm paying for right now. So for me, this represents the ultimate balance between consumption and tenant activity here, because I don't have to predict tenant activity. I just let Lambda scale based on actual activity, and I'm done. The other variation of this is where it gets interesting is when you talk about isolation, right? In multi-tenant worlds, we often have this really strong need to figure out, offer our tenants an isolated environment, right? You can imagine in highly compliant environments or legacy environments, people will say, I am not willing to run my infrastructure alongside some other tenant. I have to be guaranteed some really hard boundary. I don't want them running on my boxes. I don't want them side by side with me in my storage footprint. Please give me a siloed environment where all my stack is running. And that happens all the time, and then we come up with all kinds of creative ways to try to offer them that siloed environment without sort of undermining our DevOps and undermining all the cost footprint and everything else. But ultimately, those siloed environments in a traditional model end up having a fairly significant cost footprint to them. Also end up with a fairly significant provisioning footprint to them, right? Even if I have full automation, well, if I have to automate the provisioning of an entire stack for a tenant, that's a pretty lengthy and heavy-duty process. And no matter how well I try to make this downsize and scale down at night, even if tenant 1 is doing nothing with this system at some hours of the day, there's going to be a cost footprint associated with that. And so what we do in that scenario is we say, well, you asked for a siloed environment, so we're going to charge you more because you're a siloed customer, and we sort of justify it all that way, and it all washes out and it works. But it's not a very clean way to attack the problem. And so for me, this is where the value of serverless and SaaS really line up in a very effective way, right? Imagine now that same question, right? I need isolation. It's essential to me, but I'm going to use a serverless stack to solve that problem. Well, now in the serverless stack model, yeah, I've got all these functions deployed out there, and these functions can be for my shared multi-tenant environment or for my siloed environment. They're all still just functions deployed in Lambda, and then those functions can be executed in an IAM context. So I can essentially say, I'll take identity and access management, and when I invoke this function on your behalf, siloed tenant, I'll make sure I invoke it with the appropriate IAM context. And now all the resources that are invoked from that function will be scoped and controlled based on the IAM privileges of the context that was given to that function. So if I'm hitting DynamoDB, or I'm hitting RDS, or I'm hitting any other AWS resource, I'm going to hit it in the context of that IAM, those IAM security policies. And for some tenants, that will be a reasonable level of isolation. The reality is, for some, that still will not. But assuming that tenants get more comfortable with that notion and tenants are more accepting of the serverless kind of model, now think about what that does to my cost and load optimization. Well, now when tenant 1 is doing nothing, truly doing nothing, say they're in a certain geography and after hours they have no load on the system, I have no load, no compute load at least, on my system either, unlike the traditional full stack ISO model, right? So for me, the fact that they're isolated, the fact that they've asked for isolation, doesn't somehow now represent, oh, you truly need a fully separate experience, right? I can now provision their environment with the same mechanism I provision the shared environment. I could even argue there is no such thing as isolation with SaaS, serverless SaaS, because I could say every tenant will execute in a IAM context, and aren't they all really just isolated from a compute perspective at that point? Isolation suddenly isn't such a big deal. So I feel like this is probably down the road, but this will be a very compelling model for optimization and for isolation going forward. So what are the key takeaways here? Well, hopefully you get the sense that multi-tenant loads are really hard to profile, right? If you don't sort of buy that, you don't buy the rest of the optimization story, right? If they're predictable, we could probably figure out manually what the knobs and dials are that we need. But I believe, in my experience, is that they are entirely unpredictable. And in fact, the fact that I'm adding new tenants all the time, I don't know what those tenants are going to do. So I need something dynamic that can respond to alterations and changes in the load. This truly relies on very granular metrics, right? You've got to have a good aggregation of metrics here that can give you the data you need. Here's an important point, which is, this is all great that we want to keep these two graphs aligned as much as we possibly can, and we'd like that gap to be as small as possible. But as much as I'd like to sort of live on the edge, I'm still going to be a little bit cautious there, right? I'm going to give myself a gap. The worst thing would ever happen to me is I go and show somebody that, hey, we are just nailed optimization, and then some tenant is having a bad experience because my optimization is just a little off. I'm going to give myself a little bit of room there, a little bit of cushion. And then hopefully you see that serverless is truly a great opportunity here. The last area I want to hit on is data and metrics, right? And I know I've emphasized this, but I really want to hammer this home, which is start this process by figuring out what metrics you think will tell you interesting things about your particular domain, right? I'm telling you that if you have that and you invest in that, even if you don't know what optimizations you need, or even if you think there aren't chances for optimization for you in the future, right? Like we've done it. We've tweaked and tuned everything. There are no opportunities for optimization. I guarantee you if you invest a ton of energy and really think hard about what metrics there and you instrument those metrics into your environment, you are going to find interesting and creative ways to tune your environment in ways you did not expect. And I will say that those metrics, as part of challenging you to find those metrics, it's about not just about getting the traditional metrics that we can already get from any number of sources. It's about looking at the trends of usage in your environment and the interesting bits about how people are pushing your application. And guess what? When you have that data, yes, it's going to give you cool ways to optimize your app, but it's also going to save you a ton of time and energy in terms of thinking about what problems are waiting for you. Because as you start to surface these metrics, you start to also find issues in your underlying architecture you didn't know were there. Oh my, I had no idea people were experiencing this particular problem or how long they were waiting for this particular thing to run. And yes, we thought we had everything captured, but now we're finding scenarios where that's not true. So push hard here, be creative here, and it will open up your door to optimization. So last bit here, hopefully it's clear that there's a real opportunity to take a narrower view of just figuring out which tenants are the tenants that really can benefit from optimization and that we can use data and be dynamic about deciding who needs it and how to resolve it and do it in a way that we don't impose a huge infrastructure cost on our organization. In general, I mean, I have a whole blog post written just about profiling tenants, right, and understanding tenant profiles. And this will give you a chance to develop a really rich profile of what your tenants are doing. And I believe being equipped with that profile is going to be useful to you in many contexts. Hopefully you will see that data distribution is going to affect the optimization strategies you have around how you represent data and which storage services you take. And in general, I'd like to see you take advantage of the diversity of AWS storage services here to make all that work. And then I've already hit metrics and monitoring as hard as I possibly can, so I won't say it again. And for whatever you do, don't make cost somebody else's problem. Make cost a real part of your equation. It usually already is. But I will go ask people when I'm reviewing their architecture, what's your cost per tenant? Like so many people say, I have no idea. We don't bill based on that. We have an entirely different plan. Our SaaS model isn't driven by that. Well, but the business still cares what cost per tenant is, don't they? And as you introduce new features, do you want to know how that's going to affect the cost per tenant? I want to know that number, and I want to know how my architecture is going to affect that. So go after that number and make that number part of your equation because it'll probably affect which optimization strategy you choose as well. So that's SaaS optimization. I hope that was valuable to you. I would definitely want to emphasize the fact that this is probably like the tip of the iceberg of possibilities. I think this is an evolving space, and I think there's lots of opportunities. I certainly love to hear from any of you. Send me an email if you've got some creative way you're doing it so that I can sort of expand the repertoire of possibilities here. But I really appreciate coming today, and I hope you enjoy the rest of the conference. Thank you.